Okay, in this lecture I'm going to show you all how to deal with violations of the assumption of data. So right here I've got the Kickstarter final project, and the likelihood of you guys having data that looks really bad is pretty high. And the problem is that people deal with this all the time. When individuals are testing data, when individuals are running hypothesis tests and trying to derive information from the data, they have really bad data, but they ignore how bad the data is. And so let me show you what I'm talking about. So the very first thing that I'm going to do is I'm going to go to data and click on data analysis and click on descriptive statistics. Okay, so descriptive statistics, this is in the single sample, and I am going to say, okay, what data do I want? And I'm going to delete this. Let's see, and I'm clicking on the first one and I'm pressing Control down, and it'll bring me all the way down to the bottom. And then I'm going to scroll up to the top, press Shift, and click on the label in the very first row. And then I'm going to say, okay, there is a label in the first row, and where do I want this? I'm going to delete this, the output range. I'm going to put the output range right there under descriptive statistics for data analysis tool. And then down here I'm going to say, hey, I want the summary statistics, I want the confidence level for the mean, and I put 95% because my alpha is going to be 0.05. And then I want the k largest, this means that I want the max. And then this one right here, when I have the number 1 right here, it means that I want the min. And I'm going to press OK. So this right here gives me the mean, the standard error, gives me tons of information, and it gives me the max, and it gives me the min. Now this is a really big difference, okay? And there's a slight problem with this data, with how large this range is, and I'm about to show you guys. Okay, so I'm going to once again highlight the entirety of this data, and I'm going to make a box and whisker plot, because you guys are going to have to make a box and whisker plot. So I'm going to click Insert, Box and Whisker, and you'll notice here, box and whisker, I'm going to put failed software projects. Okay, and you'll notice here, what I tell you guys to do is add the chart elements and put the data labels to the left. And you'll notice when I ask you to put the data labels to the left, you can't see much of anything, right? Let's zoom in a little bit just to make sure. We have this data point all the way up here, which is 55 million. There's a Kickstarter project that was trying to get 55 million, and then all the rest of these that are outliers. And then 75% of the data is at this tiny little line right here or below. And so we've got a few options here. Okay, so the first option is to run it just like this. And I'm perfectly fine with you guys running it just like this. And the reason why is because most people do. Now, I'm going to tell you straight up, it's a really horrible thing to do, and in the real world, I don't want you to do this. But for this class, I want you to understand that most people will run this data just like this with all of the outliers right there, and they will pay zero attention to the fact that this data looks this bad. Okay, and we're going all the way back to Unit 1. All the way back to Unit 1, and we are going to find the outlier limit, we're going to find K3, we're going to find the median, we're going to find Q1, and then min, mean, and outliers above, so on and so forth. So here's what we're going to do. K3 equals quartile, we want quartile inclusive. And then we are going to come over here, and we are going to highlight the entirety of this. Okay. So that's the array that we're looking at, and we want the third quartile. This is the value at the third quartile. And then we're just going to press Control C. We're going to press Control V right here. And the median is the same as the second quartile. Second quartile. And then the Q1 is going to be the first quartile. And then the minimum value that is not the outlier. So it would be really great if we could just do that, but that's not what it's going to do. So, in order to find the maximum value that is not an outlier, in other words, what I want is the upper outlier limit. So right here, you can change this to upper outlier limit and lower outlier limit. And let's delete this. And so what we're going to do is equals max minus min. So this gives us the range. Times 1.5. And then we are going to subtract that from 5,000 minus max minus min times 1.5. So this right here is the lower outlier limit. So in other words, the lowest value that is not an outlier is going to be the minimum value, which equals min, which is, well, see, the really cool thing is once you highlight the data once, you can just go like this. Control C, you can highlight where the data was, and you can do equals min, and it gives me the minimum value there. So this really is the minimum value that is not an outlier. And so if we were to do this, Control C, and put this right here, Control V, and put the maximum value, it would give us that 55 million. We don't want the 55 million. What we want is just like this, Control C, we're going to do, this right here is the range, this S43 minus S45. So what we're going to do is Q3 plus the range multiplied by 1.5. So this right here is the upper outlier limit, which is 117,500. Okay, so here's what I'm going to do. Because the upper outlier limit is 117,500, I'm just going to kind of round that up to the max is going to be 120,000. Okay, so I'm going to adjust this data to be 120,000. I'll leave this here and say all failed software projects. And then I'm going to come over here and I'm going to make a new box and whisker plot. I'm going to go down to where it says 120,000. And the reason why I did 120,000 is because I just like nice round numbers. And so it's good to have, you know, those nice round numbers. And so I had already sorted these. Sorry, I didn't tell you guys that, but I had already sorted these beforehand from largest to smallest. And so we've got the failed software projects from largest to smallest. And now I'm going to do insert box and whisker. And so you'll notice now that I have, here we go, failed software projects under $120,000. And the reason why this is also really important is because when you have those failed software projects that are $55 million, the reason why they didn't get funded is because they were $55 million. Who's going to fund a project that's $55 million? And so you'll notice, though, you know, I told you, hey, I got rid of all the outliers. Well, I got rid of all the outliers when the max was $55 million. That max and, you know, the interquartile range and so on and so forth was impacting what was considered an outlier. So when you removed all the outliers, what it did is it shifted everything. So now Q1 has changed, the median has changed, the mean has changed, Q3 has changed, everything has changed. And so now we have to modify it, and we're going to just kind of move this. I'm going to Control X, and then I'm going to, on the left hand side, let's see here, add chart elements, data labels, left. And so now you'll see, okay, we've got new data labels that we can put in here. And so we're going to put 120,000 right here. The max value that is not an outlier is now 32,200. 278.865 or 87. Okay, and then the mean, you'll see the mean right here, and it's a little hard for me to read, so I'm going to zoom in a little bit. 23,933. So 23,933, and I'm gonna 23,933.87. 0.87. And then the median, you'll notice the median is also right there, 13,500. 13,500. And then Q1, let's look at Q1, is now 5,000. And so you can see, well, not everything has changed, but almost everything has changed. I don't like it when it does this. There we go. 5,000. There we go. And so I accidentally, what did I do here? The mean is 23,000. So this, I accidentally put this in the wrong spot. Sorry about that. So that should have been Q3. And I'm actually just going to move this out of the way so that way I can have the real one right next to me. Okay. So we've got Q3 and the upper outlier limit, sorry, I misspoke before, 72,458. I'm just going to redo this. Okay, so I'm going to move this one over here because I'm not going to use this anymore. And I'm going to put the new one right here. And this is the failed software projects that are under $120,000. So now we've got to adjust what is right here. Now we have Control C. Let's do this. Failed software projects under $120,000. It's equal to or under $120,000. Less than or equal to $120,000. And so let's do a little bit of work here. Okay, first of all, it's really good to know the source data. Okay, and so remember, put the chart elements here. So we put the data labels in there. We put them to the left, and all those outliers, they are up there. So we've got the data labels here. But in order to get the source, where is this data coming from? If you go to select, if you click on it, just double click on the edge of it, and then you can say select data, and it's right there, and can press highlight everything from the dollar sign all the way to the end and press Control C, then press cancel. And then unfortunately it's going to bring you all the way back over there, so you've got to go back up to the top and over. So we've got the data, where it's coming from, and so now this is really important. We're going to put that right here as just a reference, so that way we can get to it later. But we want to know what is the upper outlier limit, what is Q3, the median, Q1, the lower outlier limit, the mean, so on and so forth. And so the really great thing is now we have this chart and we can actually see everything. Okay, so the upper outlier limit is going to be right here, the 72,458.52. Okay, the Q3 is right here, 32,278.87. Okay, then right here we've got the mean, but we're not getting there yet, so let's go to the median. The median is 13,500. Okay, Q1 is down here, it's still the same thing, Q1 is the same. And then the minimum value that is not an outlier is 22.9. And then last but not least, the mean, which you can barely see. Let's see if I can change it. I don't know. There we go. So now I can see it, 23,933.87, and then the outliers above. And in order to calculate the number of outliers above, okay, is this really great formula called COUNTIF. So what we're going to do is we're going to do equals COUNTIF, and we want to count the number of values in that range that are above this value right here. So we're going to press we're going to press COUNTIF and then paste that range in there. And then the criteria, what we're going to do is we're going to put a quotation mark, and we're going to say if it is greater than, COUNTIF, if it's greater than, and you've got to put an and symbol, this value right there. Okay, and that is going to be 155, so I'm going to copy this, Control C, Control V. So that is the number of outliers above, and the outliers below is 0, because there are 0 outliers below. And then describe the outliers. There are 155 outliers above 72,458.52. Okay, so this is how you would adjust this. Now, another great thing is, now that we have this data on this box and whisker, we can also insert, and we can do a histogram. Okay, now click on it. So we've got the histogram, and then we click select data. Let's go right here, and we'll do select data. Remember, we've got right here it says single sample, Control C, chart design, select data. There we go. So we've got this histogram, and you'll see that it's severely positively skewed. So, and also, this is not actually a histogram. And the reason why it's not a histogram, why is this not a histogram? Because it needs to have a gap width of 0. Okay, so distribution of failed software projects goal amounts. Okay, so we've got this distribution, and from this we're able to see that it's severely positively skewed. Now, if we were to have the distribution of all of them, you know, at least we can see everything here. And let's do press Control all the way down to the bottom. Right here, and then we're going to do insert, histogram. And you'll see this beautiful histogram. By beautiful, I mean absolutely horrible histogram that gives us absolutely no information. So I'm okay with you giving this to me and describing it and saying, hey, this is what we got. But if you feel comfortable doing what I just showed you how to do, there's a lot of really great information that can come from this. Um, by adjusting it and saying, hey, we are adjusting it. Now, once again, it is perfectly fine to adjust your inclusion criteria. When you realize that your data is not going to be interpretable, you've got to say, hey, how can I make this data interpretable? And the way that you make the data interpretable is by changing the inclusion criteria. And when you change the inclusion criteria, another thing that's really important that you have to do is now, remember, you've got the failed software projects. If you change the inclusion criteria, you also have to delete this, and you've got to say, okay, data analysis, descriptive statistics, and we are going to include just that. Press OK. You see how great that is? That it gives you, you copy that range and you just paste it over and over again. I'm going to merge that, and I'm going to do failed software projects. Okay, failed software projects, and so this gives us a lot better information than what it did before. Now I'm going to show you the failed software projects for all of it. Data, descriptive statistics, C10, and then we are going to put this in F8 with a label in the first row. Okay, now you'll see the means are tremendously different. The standard errors are tremendously different. The medians are close. The mode is the same. The standard deviation is tremendously different. The variance, everything about it. This is just trash. It is absolutely horrible. You can't even use it. But when you change it, you can actually use the information. Also, look at the kurtosis and the skewness. Right here, the data is so bad that you cannot use it. But when you change it to get rid of all of the outliers, you actually make it so that you can use it. Once again, you can get rid of the outliers, but you have to note, right down here, note any issues. There were too many outliers, which rendered the data useless. The outliers were removed, and only failed projects under $120,000 were included. So the data can be interpretable. This also fixed the issues with skewness and kurtosis. There are going to be a lot of data sets that are extremely skewed, or extremely leptokurtic. Like this right here is extremely leptokurtic. This is extremely positively skewed. And you, if you don't have a lot of outliers, which the probability of you having a lot of outliers with it being this bad is really high. So getting rid of the outliers and adjusting the inclusion criteria will probably fix it. But if that's not the case, you will need to run some sort of data transformation. We're not going to be covering data transformations like log transformations, things like that in this course. But just note, there are ways to fix it. But for this particular situation, for this course, indicate, hey, this data is leptokurtic, this data is platykurtic. If it's below -3, if the kurtosis is below -3, say the data is platykurtic, and should be transformed, but we are going to proceed as it sits. Or if it's above +3, the data is leptokurtic, but we're going to proceed. or with skewness, the data is positively skewed if it's above 1, or it is negatively skewed if it's below -1, but we're going to proceed, although we should run a transformation on it. So just be aware that you should run transformations on these to be able to adjust the data to increase in accuracy and interpretation. In this particular class, we're not going to be adjusting the data if it's, outside of just removing the outliers. And so that is the main thing that you're going to be dealing with bad data. And same thing, you'll be dealing with independent samples when you run the bar charts or the box and whisker charts. And then when you run the chi-squared charts, one other thing that you're going to deal with is some of you will have counts in here, specifically like the bachelor data. I give you counts for the independent and for the paired, and you'll notice it's like, hey, it's not necessarily continuous because it's a count, but the moment that you take an average of it, that's when it becomes continuous. And so because we're comparing averages of counts, we are now making it continuous. And so just be aware of that. When you take averages of counts, it makes it continuous. Other than that, I think that's all that you're going to have to deal with violating assumptions. I know that it's a little bit cumbersome to deal with the violations of assumptions, but it's well worth your time to change it.